All right. So I think it's just better for me to record our session. Yes, that's great. All right, so these are some of our materials, and every now and then I will also be posting some reading materials. One thing is I want algebra to be really, some people think that math is something mystical or magical, but really math had been discovered by people who are humans, definitely. And yeah, I have some write-up on how mathematicians, many mathematicians themselves, there were very religious people. Some of them even started studying to become ministers or to become priests, but then decided to become a mathematician. So really, math is there's no magic in there, but yeah, it's something that we would say it's really very useful and it's real in a way. All right. So now, yeah, it's important that we just this one is in the syllabus, but just to review our course requirements, definitely I expect regular class attendance. And so regular class attendance will contribute 5% of your grade. The reason for this is because I think in my belief system as an educator, as a Christian educator, I I'm I have I am a strong believer that Christian education, the purpose of Christian education is to develop Christian values in students so that you are prepared not only for service here on earth, but even, for the life to come. So our discussion will be having some values-oriented content, some real-life situations that will help you and your preparation to do service to the Lord. And so it's important that because these are not found in the textbook in the way we discuss things on values and so just by reading the textbook, some of the things that we'll be considering here will not be there. And so it's important that you interact with the course content during the lectures, share with me your thoughts, and it will help you to think effectively, creatively, and critically. So really attending all lectures that important. So I am giving some 5% contribution of class attendance to your final grade. Yeah, so this may be class or numbers, but writing is still important. So this is the first, okay, which I expect you to be submitting next week. And this one is your personal mathematics history. I want to understand you. I mean, what was your experience in math from your childhood until now that you are now getting ready to study college, college algebra? Of course, you have taken algebra in high school, but maybe more complicated because the way it was discussed, there's not very much on applications. But it's just good for me to know. Understanding your background as far as your experiences, interaction with math as a subject, all right, will help me adjust the way I teach. So that's the first writing that I would want you to do. So after class or during the weekend, try to remember your experiences and put that in writing. And so that's my first writing assignment because I need to know that before I delve into the real algebra in a way. Now, the applications of mathematics to your career, okay, some of you are saying you're in education or media or pastoral ministry or health and so on. This will be submitted at the end, towards the end of there's I think I wrote when this will be submitted, but that's on the 9th or 10th week. All right. So yeah, it's from literature search. Okay. How is math? Not necessarily algebra, but math in itself. All right. Generally, how is that applied to your own area of specialization? if you need to interview some professionals to make this a little bit more of really, empirical kind of study, then you can interview some professionals in your area of specialization, and that you will put that in writing, and that's one other writing assignment. Okay, and so both of these, and I fully believe that with or whatever you are already sure you get 10% of your grade because personal mathematics history, whatever you submit, whatever you say, you get full marks on that, and even the application. So that's the writing assignment that I would require of you. Okay. Yes, now I won't be with you in person. All right. We're learning together virtually. And so maybe even in our class discussion, you may not have the chance to speak, to ask questions or something like that. And so I thought of putting an avenue where you can reflect on your learning experiences. So I would about 8 journals every other week. Okay, I want you to submit a reflective journal where you just put on, say something. What were your experiences during the previous lessons, and of course the maybe two. It's not about the week because now maybe even whatever for next week, you might already be asked to do a reflective journal. So the two lessons, what what are your reflections? What have you learned? Were there things that were intriguing, things that were interesting, things that you found useful in our discussion? And so every now and then I will be assigning reading materials, and whatever you have read, you may have some reactions to those things that you have read, and even your questions or concerns. Of course, you can send me an email immediately, send me a text message if you have a question, and I can reply to you. Or if it's necessary, we can talk over Messenger, or maybe I'll send you a Zoom link if you really need, very detailed response to your question. But in the reflective journal, put those there, whatever your concerns are, and I'll try my best to address them. So there's a rubric that I will be using in order to grade, your reflective journal, and so that this rubric, of course, is also in the course syllabus. So I expect that the prompt submission of the reflective journal, if I say it will be submitted on Thursday, then I say, well, it will be on time if you submit no later than 10 p.m. of that day. All right. Yeah. So it's not necessarily that you submit that during that class time, because anyway, I'm not there. So at 10 p.m. of that day, the due date that I would be telling you when it will be submitted. So I would look at the relevance of what you have reflected, making sure that you're reflecting on the topics that we have discussed. All right. Okay. How you describe, not just describing your experience. And it's just good that to express what you have understood, and you try also to do some self-reflection. What is it? Why was that something that you seem to be confused about, kind of thing? Because we may not be able to talk face to face, and so I just want you to put that in writing. Your interconnections, trying to look at what have you learned and connect that with your experience during the week. Yeah, that's interconnections. And even your own self-criticism, your own biases, stereotypes, your assumptions, and whether your mode of thinking had been changed because of what you've learned during the week. And of course, questions, concerns related to the learning experience. So the points there are the point per section you will find in the syllabus, because I included the rubric, the reflective journal. Yeah. And because this is math, you need to do practice. And I would always say it's not just practice makes perfect, but it should be correct, and practice makes perfect. So it's doing homework. All right. And this has the biggest percentage actually in the grade. That's 40%. selected exercises in the textbook. Maybe the first homework I would assign what you should work on. But in subsequent homework, I want you to take responsibility for your learning. So I'll just tell you maybe for this section, um, work on one even numbered item and one odd numbered item. I would always include the odd numbered item. Reason is that one has an answer, the back of the book. So you're able to see, oh, wow, I understood it because I got it correctly. All right. But of course, I still want to, someone said, you like math, but you don't like showing your work. But that's important to show the work. All right. So I need to see how you did it, how you came about the answer. And one good news, I think I already practiced this as a math teacher, knowing that um, I want the homework to be your feedback, your whatever you've done for your homework, to be your feedback to me, whether you understood the lesson or not. So of course, I expect you to do the work independently. And the good news is, as long as you did your work, whether you got the answer correctly or not, you will be. So, like if I say, I want you to do about 10 different numbers in the exercises. As long as you do all those, showed your work, whether your answer is right or wrong, you will not be actually doing it wrong, you will not be penalized. You will still get full mark. I only want you to give me feedback that you, however, you understand the lesson. And so you just have to do the way you understood so that I can read you. And if there are things that you did not do it right, I'll, I'll put a note on that work and send back to you so that you know where you did wrong, which one seemed to have some misunderstanding in the process. Okay, so do your work, submit promptly, because if you don't submit promptly, definitely if you submit late, then that's the time you will be penalized. All right. Okay, so the 10%, if there are 10, then 10% per day of late submission in a way. So, but the idea is just do the work, and especially when you're the ones to be, and if you want to do more, then that would be great. So that I would know, some of you might want, oh, let me try this and see if I've done this correctly. And I will be, I will be ready to look at it and give you feedback on what you have done. So if you just do your homework regularly, faithfully, submitting on time, all the required exercises you've done, you're sure you'll get already 40% of contribution to your grade. All right. So I hope that's something good news. But the thing is, of course, you will have to do it on your own and work independently. And of course, we cannot afford not to have tests and examinations. I have about I think four chapter tests, two before midterm and two after midterm. And then I'll divide the topic, I mean the lesson for the first half and the second half. So actually my final exam is just whatever we've discussed after the midterm to the end of the quarter. And of course, the midterm exam will cover from the first lesson until the coverage of the uh, just before the midterm exam. So chapter test would be 15%, midterm exam would be 10%, and finals would be 10%. So the tests and examinations will contribute 35% of your grade. Yeah, so if you would have done all the others, you already have 65%, sure, as far as your grade is concerned. So I think it's only just the tests and examinations that will have some differentiation on your performance, right? So these are the course requirements. Do you have any questions? Anything you'd want to say as far as the course requirements are concerned? Yeah, by the way, I'm just wondering how maybe I'll discuss this with because this one is Zoom, and then when you write the exam submission, well, the homework you can just especially with your work, maybe you can just do a screenshot of the work and then send to me in a way, because the work in algebra you have to write. So I think your answers is just, yeah, you get a screenshot and submit, and I'll also send a screenshot to you or whatever. So any question before we move on?
I have a question.
Yes, Jackson, yeah.
So you mentioned doing the main homework individually.
Mm-hmm.
Does that mean we can't collaborate as students to go through the homework
What?
for things like
Yeah.
let's say I don't understand something.
Mm-hmm.
I can't collaborate with a student who does understand it.
Well, you can. Although, yeah, as long as in that collaboration you were able to really you understand, or perhaps you can even ask me questions. But yeah, the main point really for me is it's not about the correct answer, but it's about how you understood. So, y- w- well, I cannot prevent you from collaborating with your classmate, but and as long as collaboration would help you understand, then that would be fine with me. Mhm.
Okay,
uh
thank you.
yeah, as long as I just don't like, because in the past, sometimes some students would just, whatever your classmates would have done, then would just submit the same thing. But when the collaboration is really when it's not just getting copying or something from someone, but understanding while and you just discuss and then you do your own work. That would be fine. Yes, no problem, Jackson. Mhm.
Okay. I also had a question concerning the reflective journals.
Yes.
It says 8 journals. You said 8 for 2 weeks, or 8 per week, or
No,
for
we have it every other. It's not about a week actually, because it's every other, like, session. In other words, every other. Yeah, so it's actually in the in the syllabus. I hope you already looked at that. So, like, next week there will be one reflective journal. Then that's Tuesday. Then on the next Tuesday. So actually that's the idea. Yes. So every
to
other
do it on.
day, maybe every other day. I think I put this as a week, but it's not really that, but it's just every other day.
And we're reflecting on what we learned during class, or what we learned during personal study time, or both.
Everything during your study time, your readings, whatever you learned in class, any learning experience inside or outside the classroom on this subject algebra. Yes, inside as well as outside. Yes.
Okay.
I have a question concerning the research paper. How many pages and how long does it need to be?
Um. Okay. Let me. Yeah. Then I think I will have to even the number of words or something like that. But because sometimes it depends upon your area of specialization. Okay. Yeah, maybe you're on media, definitely math may have some very good applications on that kind of thing. I would say around the 3 to 5 pages, just like that. Yeah. uh because I will also look at how intensive, all right, 'cause I have read, I myself have done a lot of readings on applications in education, yeah, even in pastoral evangelism and whatever is that. So because it depends upon your area, so maybe about 4 to 5 pages. So I'll see and then be very specific, particularly on the number of words. Yes. So it's not that long. But then if you have interviewed, that would add, you know, there will be an advantage if you would have interviewed someone and then quote what they have mentioned to you. And so in that case, there will be a little bit more pages in a way. Yeah. Any other question? All right. So silence means, okay, so just whatever question you have, just send me a text message and I will be prompt in responding to whatever questions you have. So it's just that, sometimes people would say, why do we need to take algebra? Of course, in high school, you did algebra. But in college, so what is it? Why do we still need college algebra in a way? All right, so yes. And I think even when you were in high school, you were told by your teachers that when you know algebra, it will help you in studying other subjects. So idea is it's not just about yeah, it's sciences, you need algebra there, in economics and business, but in many other courses, by the way, even in the arts, yes, in photography or whatever, our knowledge of math is important. And therefore, because the math seems to be pervading, it pervades the whole discipline of life, then that's important that we have an understanding of algebra or mathematics in general. Okay. And you know that algebra, and this is what we will be learning in this class, the applications of algebra in the real world. Yeah, just give you an example. I get a little pension from the Philippines. And so, the practice there is they immediately deduct your 10% tithe. Yes. And so what is you don't, it's automatic that they take the 10%. So what they deposit to my bank account is already the amount that they have deducted the tithe, the 10% tithe. Now I want to give a second tithe. And so in the second tithe, it should be from the gross and not from that amount that's in my bank account, when I know that that's not really gross, that's already net of the 10% tithe. And so for me to know the gross, yeah, of that, so that I can give my percentage, the second type percentage for the church budget, percentage that I needed to help other people, that kind of thing. Then I needed to know the gross. And the only way for me to know the gross is to put that in an algebraic equation so that I can make the proper computation and do my faithful giving, that I get that the extra 10%, my second tithe, from the gross. So it's algebra is helping me to do that. And there are times when some people will say, "Oh, how much now is the," because the percentage of my pension is from what they call the wage factor for the pensioners. So some friends would ask me, "Oh, how much do you think is our wage factor?" And just the same, I just put that in an algebraic equation and then do the proper computation. So just that as an example. And by the way, in our discussion here in class, there will be a section where we say modeling applications. In other words, we have problems and we model that using algebra for us to be able to get the correct answer. So that's how important it is to study algebra. And even in getting a job, because nowadays when you get a job, they have some exams, that they ask you, the human resource would ask you to write exams. And in those exams, there will be some math questions, even when you need to get some professional license, then there are some mathematics questions there. And so knowledge of algebra is also important in getting a job. But more importantly, algebra reinforces logical and critical thinking. It is in this class that you would really be, would say, you will learn to think critically and even creatively, especially in the way you solve the problems. You think logically. In order to, Ellen G. White, and I think you know this from the book Education. It says every human being created in the image of God is endowed with a power akin to that of the Creator, individuality, power to think and to do. And that is the work of true education that I would say reflected in mathematics teaching. That is to develop that power to think and to do, to train the youth, to train you to be thinkers and not mere reflectors of other men's thought. And I would really say that the study of mathematics, okay, would be reflective of what it is that God wants us to do. He wants us to think. He wants us to be logical in our thinking. He wants us to think critically. And so algebra is making that contribution. And of course, I would just say that the study of algebra and mathematics in general can improve yourself. So in what way can you be improved? All right. And so you know how it is when you study math. You don't, it's not just reading leisurely, like
Yeah.
reading a story, but rather you when you read the when you study or when you read the algebra lesson, you will have to read it with understanding. So it improves your ability to read with understanding and your ability to concentrate. So I was even saying that whenever I study math, it's just like the way I study the Bible, all right? Because I need some concentration. And that's what Ellen Jewett is saying. And one of the chief causes of mental inefficiency and moral weakness is the lack of concentration for worthy ends. And so as you study algebra, you need to do a lot of concentration. And therefore, that improves your ability to concentrate. It improves your ability to read with understanding. And so that kind of discipline. And so someone actually said that this one was, it's still 1923 by, there's a book authored by Day in 1923. But I just love the quote. And he said, the main design of studying mathematics should be to call into exercise, to discipline, to invigorate the powers of the mind. So sometimes you would say there are even lessons. You would say, what's the application of that anyway? But it's not about application, but it is actually saying it's the logic of the mathematics which constitutes their first principal value as a part of course of collegiate instruction. Why is it necessary that even in college you need to take math? It is the time and attention devoted to them is the purpose for the purpose of forming sound reasoners and not expert mathematicians. So it's not about developing you to be an expert mathematician, but rather so that you would develop that kind of logical thinking, reasoning, critical thinking. And that's actually one of the readings, the reading that I have in the syllabus that I will ask you to do during the next several days before Tuesday is talking about mathematics is the barbell of the mind. All right, it exercises our brain, and so you are being trained to be sound reasoners rather than expert mathematicians. All right, so that's the idea. Now, so just a little, how would you study? Okay, just a little, it's just good to share some of this. Yeah, just sometimes I know that after this, some of you will be in your workstations, and maybe after your lunch, you will be having another class. But after whenever we do a discussion of actual lesson in algebra, it's just that at the end of the day, maybe you're tired, but just so that you're able to reflect on what you have done, we have discussed, then I would suggest that do today's work today. If the homework is given, try one or two, one or two exercises that you would be able to do during the day, so that it's still fresh in your mind. All right. Well, you really need to ask questions. So actually, Jackson was saying, yeah, maybe you can collaborate. That would be great. Yeah. Or you can ask that question to me, send a message, and I will. Yeah, it's important that you ask questions. Yes. Even in class, it's important that you ask questions. Review frequently, right? Every now and then, even if there's no exam, just keep looking at what we have discussed and do. Yeah, of course, I'm talking about independence. As much as possible, you work on it independently. It's on your own to begin with, so that you just have to have a self-reflection. Have I understood this or what? But otherwise, if there's really a lot of confusion, then you will have to ask questions. But begin with being independent. Do the work independently to begin with. And then you resort to asking questions when there's really no point that you will be able to continue doing the work without somebody's help. Know what you're doing. It's important that, it's not just memorizing the procedure that had been discussed in class, but understanding the principles, such that you need to redo your work, every now and then, for you to say that truly I understood the topic. All right. And of course, be neat and accurate. Yes, I would even say that success in algebra is a lot of scratch papers, all right? And of course your pen. But in the process, do the work neatly and be accurate in doing things. Because when you're doing things in a hurry, particularly, all right, you only will become accurate if you do it in a diligent manner. It's not in a hurry, because you will just waste your time if you're doing it in a hurry only to find out, especially during the exam, you know. Um, and when I say neat, it's because it's difficult. I may have the way you write your numbers may be not very clear, that I would give you, I would say this is a mistake just because I did not understand what had been written. But above all this, I just want to say that, yeah, and I think you know that in whatever subject you study, you will have to seek God first. Because as I alluded in my prayer, that God is willing to give wisdom to all who ask him generously and without reproach, and he will also be giving to you. And so I just love this quote before I even proceed to the study of to the actual discussion of Ellen G. White. I would always mention this to my students in whatever class I would teach. It's Christ Object Lessons, page 146. And I think you're familiar with this. And it says, it is not the capability you now possess or ever will have that will give you success. It is that which the Lord will do for you. So yeah, God has allowed you to be here so far. As of this moment, you're now here with me in college algebra. Just remember that, God wants the best for his children. And so it's dependence on him. Success will only will only be received through him. And it's not about our capability, but it's about what he will do for you as you seek God first in everything that you do. So, yeah, so with that in mind, knowing that we have a God who is always willing to give us the desires of our heart, and that includes success in an algebra class, then you'll be confident to face this quarter, and knowing that, God will surely be with you. All right, so those are some few preliminary things. Any feedback, any reaction before I proceed? Okay.
No.
Yes?
No. We're good.
All right, that's great. Okay. Now, I just want also to say that, of course, I have some in the syllabus. That's actually just what my plans are. But plans may change depending on the way you interact with me and the pace of the class. So really, the whatever I have written in the syllabus may not really be followed diligently, maybe a little bit late or something like that. No, I won't force, I won't be very fast. I just want to make sure that I have succeeded in making you understand the lesson. So we may actually not, we may even be, when I say that one will be the lesson for next week, it might even be, I will just continue the lesson that I prepared for this week, something like that. So it's tentative, there will be changes in the syllabus. Yeah, so that's just, I just want to say, because my main aim as a teacher is for my students to understand whatever lesson and get something that would be useful in life as far as our lessons are concerned. Okay, so let's just proceed. All right. A little bit of the history of algebra. So as I already mentioned, math is not mystical. It's from people. Okay. So the founder of algebra and algorithms, this is an Arab mathematician, Muhammad and Musa al-Khwarizmi. Well, I think I just want to, there's okay, sorry. Okay, so that algebra, it's actually a Latin variant of the Arabic word algebras. It actually came from the Arab mathematicians, yes, because he had this title of the book that he wrote, Hisab al-Jabbar wal Muqabbala, something like that. So this was about AD 825. The mathematician, so Muhammad ibn Musa al-Khwarizmi, in English, it's Muhammad, son of Moses, the Khwarizmite. All right. So if it's difficult so that's the meaning of that name, Muhammad ibn Musa al-Khwarizmi, Muhammad, son of Moses, the Khwarizmite. All right. So he is the founder of algebra and algorithms. And I think this is the reason why the word algorithm, it came almost from his name, al-Khwarizmi. All right. So the idea of this book, when he's talking about this algebra, is saying that the algebra is actually the science of restoration or reunion and opposition. Reason is when I think you did some algebra in your high school. We do lots of transposition, cancellation, especially when we solve equations. So that was the basic algebra, solving equations, algebraic equations, where you transpose some of the terms to the other side, and then you subtract from this side as you add to the other side. Okay, cancellation of equal terms on the opposite sides of the equation, which is the very basic principle in solving equations. So it began from there. And then he moved on to say that really algebra is the science of equations. Yeah, because we do modeling of real life problems using algebra. And so when I say modeling, you put an equation so that you can find the solution. So algebra is actually really the science of equation. And I just love this. Yeah, because algebra is considered to be, in general, we talk about mathematics, but it's in algebra that we are able to really apply the language of math. So it's important that we understand the terminologies every now and then. I would have to introduce meanings of terms and something like that. So algebra is considered language of mathematics. Yeah. So even in the elementary school, you were introduced math, and what you've learned was about arithmetic. So actually, algebra is just the generalization and extension of arithmetic. Because if arithmetic is just about the certain operations, addition, multiplication, subtraction, division, on specified numbers, then it becomes algebra when we now apply the different properties of math, like commutative law for addition, associative, which we will be talking about in a little while. So you just extend your understanding of arithmetic to algebra, when now instead of talking about numbers, we represent numbers by letters. And so we study letters rather than just numbers. Okay? So arithmetic is very much into the numbers, but then extend that, generalize that by saying that there's a letter that may represent any number. But then it has also a relationship with geometry, because algebra is written geometry, while geometry is pictured algebra. So talk about arithmetic, talk about geometry, then they can be put together and have that algebra. So so geometry, that's a picture, but then you know how geometry is, but then you use algebra to put that in writing and fully understand those pictures. So that's what algebra is all about. And so if algebra is the language of math, oh wow, I just want to relate this with what Galileo Galilei, wrote. Okay, in general, what he has written can be summarized into saying that math is the language with which God has written the universe. So if algebra is, of course, written geometry, so I think it's Galileo was really saying God is a geometer or a geometrist. Because it says the universe cannot be read until we have learned the language and become familiar with the characters in which it is written. It is written in mathematical language. So if you look around, there's lots of mathematics in nature. And the letters that God used are triangles, circles, and other geometrical figures, without which means it is humanly impossible to comprehend a single word. In other words, you will fully understand nature from the eyes of math, particularly geometry. Okay, and without this, one is wandering about in a dark labyrinth. And so I have also a few readings to expound on this that I will be sharing with you. I'll ask you to do some of these readings on how mathematicians look at math in terms of, the spiritual sphere. So maybe I would say, well, that's why I just praise the Lord for making me a math teacher. Yes. And just, because this is the first was a meeting we have, so I just want to spend a little bit more time on sharing my experience. Did you know that I started in my first 2 years of college? I actually trained to be in the area of religion. Yes. Just like you, I wanted to be, who said that, Tarsus, yes, who said that you could not even think of, a profession, but to serve the Lord. I was that. Since young, I wanted to be a pastor. That's really the truth. And so when I entered university and entered college, I took Bachelor of Arts in History and Philosophy of Religion because I wanted to be a pastor. But for whatever reason, whether that person, that guy, the pastor, after having, I stopped schooling after my first year in college because my father, my uncle who was my adoptive father, died. And so I went for evangelistic campaign. And I was the health lecturer. I was doing Bible study. After a successful evangelistic campaign and coming back home, the pastor who sent me to that evangelistic campaign talked with me, and it was a surprise when he told me, I heard that you have a some good understanding of math. I wonder why do you want to be a pastor? I think you will be yeah, not very many people like math. There are many of those who can be pastors. Why not take math as a career instead of being a pastor? Imagine. So he tried to discourage me. And and sorry to say, because he also said, and don't you know that women pastors will not be ordained, especially in our country, in the Philippines. So since you will not be ordained anyway, let the men be in the front line. Okay. Take another career that you will be more useful. Oh, so that was I just feel like will I not be useful in the ministry? and then you know what he said, this is my suggestion. If you really want to get involved in the ministry, then you be a pastor's wife. Instead of being a pastor. So you just imagine that kind of thing. And I don't know, I kept into thinking into that. And so when I went back to college, even my other teachers were telling me, yeah, you're good in math. So why not take math instead of so I don't know whether I was thinking who even gave that thinking in them. Is that from above or from below? So and some even said you'll get lots of scholarship. Yes, I was poor, I was a working student. If you take math. And so, well, with lots of prayers and crying, I decided to shift to math. Okay. And just prayed, Lord, make me a pastor's wife. Yes. So that was my aim. Now I will be in math and be a pastor's wife. And so I made sure that I would deal with pastors, with the people in theology. And I got one who was taking theology. We were together in voice of youth campaign, kind of thing. Yeah, so I said, well, praise the Lord. I got someone in theology, because this is what he was my first love and whatever is that. So he was in theology. So then I'll be a pastor's wife, and at the same time I'll be in math, okay, teach math and whatever. but God is humorous. Because as soon as we got married, and he finished his theology, his AB history and philosophy of religion. after after we got married, he talked to me and said, I want to go back to school. I said, why? You know what? I'm really more interested in technology than in theology. So, so I said, no, what happened? So what can I do? We're already married. So he decided to go back to school and take technology. And I really asked God, what is it? Why is it? I wanted to be a pastor. You told me take math. I wanted to be a pastor's wife. I married someone who finished theology. Now he is in technology. But then I realized that really God has a different purpose. And that purpose is he wanted me to have the mathematics classroom to be my area of ministry, to be able to bring students into full understanding of God's love through my mathematics teaching. And perhaps if I were not in the area of math, I would not go all over, go to Thailand, do a ministry there as a mathematics teacher, move on to Africa and serve the Lord there, not only through my mathematics teaching, but even in many other areas. And so God has a plan. So I just want to say that I am with you, okay, for those in the pastoral kind of thing. Yeah, in a way, because I know that, I only can, I would in that the document that you will be reading, this first reading, I would even say that, okay, it is in mathematics that you are able to probe into the mind of God. That may be something very strong as far as from a mathematics teacher or from people who are in the area of mathematics, but that's really true because the the language with which the universe was written is the language of mathematics. Okay, so you may disagree, but try to look around and you'll be able to see that there are lots of math around you. Okay, now, okay. So I think, yeah, we have about 30 minutes or so just to begin really with math. So this is the first lesson, and I just want you to get excited the way I'm excited in learning mathematics. Well, you know how it is with arithmetic from your kindergarten. Yeah, in the whole elementary school when there was no algebra yet. Yeah. You did arithmetic, basic arithmetic operations, and you just dealt with natural numbers. And when we say natural numbers, that's of course counting numbers from 1 to infinity. Whole numbers, when you're now adding 0 to the natural numbers. Yeah, just add, subtract, multiply, divide. But of course, in algebra, we go beyond the whole number system, which includes the natural numbers. And so we'll be actually discussing what we call the real number system, where the natural numbers, which is a subset of the whole numbers, will already be, will go beyond the whole, but move on to integers. Where definitely when you talk of integers, there are already negative numbers. And sometimes in the past, just introducing negative numbers in the area of algebra, some students would say, oh, what are negative numbers anyway? Only for us to know that really we have lots of negative numbers. Talk about temperature, okay? So you have a positive degree Celsius, 0 degrees Celsius, but then you go below 0. We have a negative. All right. I don't know how it is now in Heartland. Here, of course, in California, we're okay. And I'm talking now of the Celsius. We're okay because it's not very cold here, but maybe there in West Virginia, I'm not sure about that. So there can be some negatives, you know. So you talk about
It
profit. How is it there? What's your temperature?
Around February in the mornings, it can drop to like teens, but that's not always every year. February is the harshest month of winter. Other than that, it can be a little bit like freezing in the morning and then 45, 50 during the day and then freezing during night and frost.
Okay. Yeah. So really about the freezing and kind of thing, that's something negative. All right. So I'm dealing with Celsius because of the 0 thing there. So 0 to the temperature can go up and down. Talk about profit and loss, or perhaps break even. Break even is 0, profit is positive, loss is negative. So you really do a lot of positives, negatives, the up and down in the stock market. Okay. Well, I don't know, maybe you're not into that, but some people will just look at, oh, is it up or is it down? So sometimes the negatives, you say, oh, what is that? Especially when you're just beginning from arithmetic moving on to algebra. But really, negative, there are lots of negative numbers that we talk about your income, yeah, and your debt, yeah, or in the bank you deposit, that's a positive. You withdraw, that's negative. There's no transaction, then that's 0, something like that. All right, so it's not just about this natural numbers, whole numbers, integers, but we also move on to rational numbers. So it's not just the whole negative 1, 2, 3, 4, and so on, or positive 1, 2, 3, 4, but fractions, because really there are fractions, right? And we move on beyond rational numbers, we call irrational, where that number cannot be written as a fraction. So these are the things that the numbers, the kinds of numbers that we study in algebra. And so when we talk of rational numbers, it can be written in a decimal form. Okay, so there are rational numbers, there are fractions that we call it a terminating decimal. When you say 1/2, that's 0.5, you know? You say 1/4, that's 0.25, 1/8, that's 0.125. But of course, there are also fractions that when you change it to decimal, will not end. Rather, numbers will repeat. Okay, so that when you divide 11 divided by 9, you'd have 1.2222222, and that's forever. Okay, it won't end. Or you divide 1 divided by 3, right? Yeah, you say 0.333333333. Okay, then 2 divided by 3, 0.6666666 until the end, and it doesn't end. So we call this the non-terminating but repeating decimals. All right. So so that we would show that it is repeating. Okay, the symbol that we use is, we call it vinculum. It is line segment on top of the numbers that are repeating. So you would have this 1.2222, okay? Then you just, the 22 is repeating, so you can just put, we call it vinculum, vinculum, vinculum. Okay, repeating. But there are numbers that cannot be written as a fraction. And we call this the non-terminating, non-repeating decimal. And one of this is a pi. Okay, so well, of course, you can ask the calculator to do pi, all right, and then it will give you 3.141592 until maybe if your calculator has 12 digits and it ends there. But it doesn't mean that it ends there. It doesn't end. Actually, they say that someone used computer to generate the number pi, and they continued generating, type it in a stack of paper, and it reaches to 125 feet high, and the numbers still continue. Okay, so in other words, it doesn't end, at the same time it doesn't repeat, and so we call this now irrational numbers. When you talk of square root of 3, square root of 2. So we will be talking about a lot of these irrational numbers in our discussion. And so this number system is, of course, represented by what we call a number line. All right. So, of course, we just had the 1, 2, 3, 4, but there are numbers, infinite numbers in between. Okay. Those segments. Yeah. 0, 1, 2, between 0 and 1, you have an infinite number there, and so on. And so we now have the origin, the positive, and the negative. And so we talk about infinity, infinite. I'm just so happy that it is math that would help us understand what infinity means. All right. And it is using the number line. So I just want to make it a vertical kind of thing, just to associate this with something that I just want to emphasize also in our discussion of the origin, and it is now infinite going up, infinite going down. Or you can put it horizontally, infinite to the right, infinite to the left. And so there's such a thing as infinity to infinity. The infinity going down and up, infinity from the left to the right. And so that's why I just love math, because the only way I can represent the infinity of God is through this number line of infinity, from infinity to infinity. And Psalm 90 verse 2 says, "Before the mountains were brought forth, or ever thou hast formed the earth and the world, even from everlasting to everlasting, thou art God." Yes. So from infinity to infinity. And so understanding, this may be a very, not a very, that's a perfect representation, but it's a representation of the infinity of God. Okay, our number line. But I just want to move on with this line, number line, as a number line of God's blessing, or line of God's blessings. Yes. Previously we were sinners, and we accepted him. And so he brought us up from being negative to positive. Okay. So now, from the acceptance of Jesus, We may be just first at the origin, okay? He lifted us up. But he said, well, I have more blessings to give you, not just lifting you up from where you were, being a sinner. But that line of God's blessing is talking about what he promised in Ephesians 3:20. Now to him who is able to do exceedingly abundantly above all that we ask or think, according to the power that works in us. And so it's infinity from that zero where we are, moving up. And really, God's work is innumerable. It's really infinite. Okay, and that's in Psalm 40, verse 5, O Lord, 0.5, my God, you have performed many wonders for us. Your plans for us are too numerous to list. And so that's that line going up, numerous to list. If you have no equal, if I try to recite all your wonderful deeds, I will never come to the end of them. And that's infinity. And that infinite kind of thing goes beyond this earth. Okay. So that's why it was that blows my mind to think of that kind of infinity that this number line is representing, because I just love this. 1 Corinthians 2:9. All right. However, as it is written, what no eye has seen, what no ear has heard, and what no human mind has conceived, the things God has prepared for those who love him. All right, so in the blessings of God, I would represent that as a number line from the zero going up and hoping that we're not anymore going down, all right, to the negatives, but move up until eternity. Yes, so that's what number line is all about to me. Okay, which is now the real number system in algebra, right? So it's just infinite numbers in between the different line segments right here. Okay. And so we put that in a step. So we now say that we begin with the natural numbers, natural because it's counting. And that is a subset. Okay, I just want to use now the mathematical term. It's a subset of the whole numbers because you add 0 to your counting numbers. And then these whole numbers, you add negatives there, and that will now be a set that will enclose it, will be integers. The book uses I, so please take note when I write N, okay, maybe next meeting I will, instead of PowerPoint, I will be doing a lot of writing, okay? Through my show me, or the app that I will be using. N is the symbol for natural numbers. W is a symbol for whole numbers. Our book uses I for integers, but most books use Z. Okay, Z as the symbol for integers, and then for rational numbers, which is now the bigger set. And under the rational numbers, the subsets are the natural numbers, the whole numbers, and of course the integers. It's denoted as Q. And this is M over N, where N is not equal to 0, knowing that you cannot have 0 as a denominator. And then outside of this set is the irrational numbers, our pi, square root of 2, square root of 3, and other things. And we represent that as Q prime. All right, so really, the real number system is considered to be a set. And then the bigger set is, of course, your rational, moving into integers, to whole numbers, and to the natural numbers. And of course, there's an outside kind of thing there on the set of irrational numbers. All right, now just to remind us of our operations on signed numbers. Yeah, I believe that you still remember, but I just want to take things for granted. It's just good for us to remember. Yeah, in arithmetic, very easy because our teachers so just deal with whole numbers. We add, yes, all positives. And when they ask us to do subtraction, they actually don't give us a problem where you subtract a bigger number from a smaller number, they will say, oh, that cannot be. We don't subtract only the smaller number to be subtracted from a bigger number. But, when you entered algebra, that's not the case because you can subtract bigger number from the smaller number kind of thing. But anyway, so that's why it's important that we deal with signed numbers. So when you're adding, when they have the same signs, both are negatives, you just add the value, the number, and then take the common sign. All right. If both are negatives, then just add the two numbers and take the common sign. If they are both positives, of course, add the two numbers and the answer will also be positive. However, if it's a different sign, you will subtract. Okay. And then take the sign of the largest absolute value. In other words, whichever is a bigger number, whatever is the sign of that, then that will be the sign of your final answer. But when there are different signs, it's actually just subtract. So that addition is considering both adding and subtracting. But anyway, if ever you subtract, we will be learning more later on. We just change to add the opposite. So what do I mean by that? When I say -3 minus +4, you take the opposite sign of +4, make it -4, and then you add. Okay, so let me repeat. When we're subtracting, the opposite sign of the one that you are we call that the subtrahend, all right? Take the opposite sign and then use the addition. Reason for this is because addition and subtraction are inverse operations, all right? So when you subtract -5 minus -9, you change the sign of the -9 to plus, okay? And then proceed to addition. And then follow the rule for the signed numbers. So actually just saying that when you have a minus and a minus, it becomes a plus. But we'll be more doing things in detail later on. But the idea is change the sign of the opposite. I mean, the sign of the number that you are subtracting, and then proceed to the process of addition. Okay, it may be a little bit confusing, but you will be doing lots of those. Now, anyway, so that's for addition and subtraction. Okay, and so many times I just want to say, let me the easier way of remembering. Okay. Okay. And I just want to use the representation of loving and hating. I hope nobody hates anybody. But anyway, there's something like love and hate, where love is the positive feeling and hate is the negative feeling. And so, yeah, just to represent that, I would say if you add love and love, that will be actually love. Because so positive plus positive is positive. But if you have more love than hate, yeah, then actually you are subtracting. I mean, it's saying actually you are doing some subtraction in a way, but let me just say it's adding. Where the minus, of course, will be subtracted from the other one, and the one with the number with the greatest value will get the sign. So I would say more love than hate. Well, that is still love because you go into the idea of you want to love more. All right. When you have more hate than love, then the final answer is hate, and that's negative. All right. So we're saying the number with the greatest value will take the sign. And of course, when you add hate and hate, definitely it will just be hate. Okay. So that's the idea. Anyway, so for the multiplication and division, well, that's easy to remember. If you have same sign, positive times positive is positive, negative times negative is positive. Okay. And then when you have different sign, positive times negative is negative, and negative times positive is negative. Okay, so just using that idea of love and hate, I just decided to say this, that when you love to love, then you love. But when you love to hate, then you hate. So when you multiply positive by negative, that will be negative. And when you hate to love, you're actually hating. When you hate to love, that's hating. So negative times positive is negative. But when you hate to hate, than you love. All right. Yes. So that's negative times negative is positive. Anyway, just dealing with some of these words. I just tried to coin some of these things. So we will be dealing with some operations of signed numbers. So I am just reviewing whatever you have learned in the past. Okay, so that's the idea. Now, and remembering how to perform calculations here in algebra, we'll be using some grouping symbols and how to, do the order kind of operations. When you have the grouping, it's either the parentheses or the brackets or the braces. And then sometimes we deal with some exponents, including radicals. And then you multiply or divide, and when you add or subtract. So according to the rule in math, you use the order as PEMDAS. If there are grouping symbols, you perform first the operation that's within the parentheses. If there are exponents, you first do the raising to a power. Then, if there are multiplication or division, you do multiplication division first before addition subtraction. Let me explain that in more simplified way. So these are the steps. When you have a mathematical expression, the first thing is you first simplify the expression within the grouping. And then when there are exponents or radicals, that's the next thing you will do. Okay? If there are multiplication and division together, do that one first before you add or subtract, but the order should be do it from left to right. Okay? And so if there are addition, subtraction together, so that's the last thing you'll have to do, the addition, subtraction. But if they are together, you will have to perform the operation from left to right. Okay. Now, so that you don't get confused, because if that's your answer will be wrong if you don't follow the order. So first the grouping symbols, then the exponents, radicals, multiplication, division, and addition, subtraction. We call this PEMDAS. So just to give an example, this one is for us to just remember. Just suppose I have this, some of you can do it, just do them at the same time, but I just want to follow the order. So according to the steps, you begin with working on the expression, mathematical expression within the grouping symbol. So the one that has a grouping symbol here is this 3 times 2. So you do 3 times 2 first, and that's 6. And then you do the 6 plus 2. All right? Because this is within the grouping symbol. Okay. So that's why I had it as, I just copied it. Yeah, if you already know what to do, you can do all the things together, but at the same time, it's just good to show the simplification. So I first did the 6 plus 2, and that's 8. All right. And so then it says, I think I should, okay, maybe this one, this next line, I'd rather not, I'll just, okay. So you now do the ones which are what's that? The power, okay? So the power. So let me just move on to, I think I should have done this for still 4 times 8. Okay, so sorry for that. I wish I could just write. So we begin with squaring first. So 5 squared is 25 minus 4. And then we square 6. And that's 36. Minus, I could have just put this 4 times 8 anyway, but that's really 32. We know it's 32. And then the one inside the radical is 11 minus 2. All right. So then what we do is, since this is on top, the 25 minus 4, then we say 25 minus 4 is 21, and divide that by 7, plus 36, which is the square of 6. And then 4 times 8 is 32 minus the square root of 9. So we first remove square root of 9. Whatever is square root of 9, which is a 3. Now, this is what when it's addition, subtraction, multiplication, you know that you do multiply first before you add. But when you are having the same addition and subtraction in the process, make sure that you do the operation from left to right. I think that's what I want to just emphasize. So, you now do 3 plus 36 is 39 minus 32 minus 3. It's just from left to right to make sure that your answer is correct, right? So do not subtract 32 minus 3 first before subtracting from 36. No, it should be left to right. 3 plus 36 is 39 minus 32 is was that 7, and then minus 3 is 4. Anyway, we'll have more of but really I would say that in algebra I would always make use of grouping symbols to make things easier. All right, the way I do in my class, rather than make it too complicated, I use grouping symbols in order for you to say that this one is a group, this one is another group, and then that's the time I will do the operation. So in all my exercises, I would always doing grouping so that you're not confused on which one to come first. Yeah. So I group, and then in that grouping, when they are all together, just make sure that you are doing your operation from left to right. So that's what PEMDAS is all about. Okay. And so just to wind up the discussion, so that next meeting we will be dealing with the applications of the properties of real numbers. There are different properties that need to be understood. Okay, and one of these is what we call the commutative property, such that when you talk about 2 plus 3 is the same as 3 plus 2. Okay, and when you say 2 times 3 is the same as 3 times 2. And that one is, you know that. And you know, one nice thing about this is also applicable in life. There are activities that are commutative, that you can do one first before the other. But there are also activities that are not commutative. Can you please just give me some examples of activities that are commutative in life? Yeah, you can. It doesn't matter. What's the order? You can do one
Something that you
first
can do.
or the other, or vice versa. Can you give me an example?
Like cooking,
Uh-huh.
when you're like measuring the cups.
But sometimes it matters.
Yeah. So when you cook, what will you do first? You can.
And
You are already
sugar, because
cooking before measuring. Yeah, maybe before measuring your salt. Okay.
do the oil and the wet at certain times.
Sometimes it does make.
So if you're doing all the dry, it doesn't matter whatever you put in, as long as it's measured, you can dump whatever in what order. If it
Yeah.
says to like add, like do all the dry, then add in the wet, that means that you have to like separate all of the dry and all the wet before you can put together.
Yeah.
You can't just put like oil and flour and sugar and
No, it doesn't make any
no, you can't. It's gonna mess up like the cookies. Like there's a balance.
Okay. So now putting the wet in the dry, can that be commutative? It doesn't
Yeah.
matter
Yeah.
whether you put the wet first before the dry.
Sometimes, but sometimes
sometimes
not.
it does matter.
Sometimes it
But-
does. Okay. Yeah. So especially
Every-
when you're, I don't know, if you're baking a cake, is that you should do the dry first, put them together before you put the wet, or yes, all right. So anyway, so there are activities, but there are really activities that it matters. Like maybe wearing socks and shoes. That will not be commutative because you cannot wear your shoes first before you wear your socks, right? All right. So even this commutative property has some practical applications. There are things that you should be mindful, okay, of which one comes first. But there are those that it doesn't matter. So we call that if it doesn't matter, then we call it commutative property, right? Then we will consider what we call the associative. Yeah. So when you have now A plus B plus C, okay, where B plus C had been put together, it is the same as you put together A plus B first before you add the C. Okay. So similarly with multiplication. A times B times C is equal to A times BC and so on. Now, there's such a thing as distributive, which is very much important, especially when we move into factoring kind of thing, yeah, where we distribute. This is now distributing multiplication over addition or subtraction. Where you say, if you say multiply A times the combined B plus C, it is the same as distribute A times B plus A times C. Okay. And then there's such a thing as identity property, where you say there is a real number as considered to be additive identity, where you add 0 and a 0 to any number, the answer is still 0. It's still the answer is still the number. Okay, sorry about that. But then there's this multiplicative identity, which is a 1. You multiply any number by a 1, and your answer is the number itself. Yes. So A plus 0, anything that you add 0, you get the same. You multiply 1, you get the same. All right. And of course, our inverse property, where we say that addition and subtraction are inverse operations. All right. So that this an additive inverse, which is the negative, which is very much associated with subtraction. That when you add the negative of a positive number, you get the additive identity called 0. And then there's what's a thing as a multiplicative inverse, which is the reciprocal, which is very much associated with division, where you multiply A by its reciprocal, any number by its reciprocal, then you get the multiplicative identity, which is equal to 1. All right, it's just good to remember some of these properties. Many of these we will be applying in our application. I mean, we apply this in solving problems in algebra. So just today, I just want to consider some of these properties. Next time, we'll be talking about some rules of exponents and many other things. So I think that until next week, we're just reminding ourselves of some of these properties, some of these principles, so that you'll be ready to delve into some algebraic problems, the things that we want to do in this class. Okay, so let me just stop share and maybe, yeah, just so. Okay, so that because I am recording, but I just want to say that you saw the syllabus, all right? And have you downloaded the book?
Yes,
You
I
already
have. Yeah. Like when you go into the courses and you go into
Yeah.
the college algebra, on the ultimate right side, it shows like links, and then you just click under it and it'll take you directly to it.
Yeah, so here in the syllabus, I'm sorry about that, just for the sake of, okay, I'm sorry again. All right, so in the syllabus there's here the Math112 textbook. So just click that, and there you will be able to download. Okay, then yeah. So of course, the website that I mentioned. Okay, so once you click that, it gets to there, and then I actually have our classes. Yeah, so in that our classes, yeah, there's now this current class, which is college algebra. I will be putting a few things there for you to be able to download. Okay, yeah. All right, so for this time, okay, so this is of course our syllabus, right? And in this syllabus, I think I have written here the assignment. The assignment on the computations, that one will not be, you don't need that. All right, you will not work on it. I want you to write a personal mathematics history, and then it's just good. Read this article I have written in the Christ in the Classroom, integrating Christian values and learning in the teaching of math. And so that, it's just good to read, because this, I think I introduced there some reasons for the teaching and learning of mathematics. And that one can be taken from here. So you just click this, integrating Christian values and learning in the teaching of math. And that's now, it's not much. It's about how many pages? Yes. So read this article, and you'll get more information on why do we really need to learn math, and why do as teachers we need to teach mathematics. Okay. So yeah, we're just on time. We are almost okay. So that's it. So those are the two things I will be. So somebody was asking about the reflective journal. Where are there 8? This is the way I do it. Like next week, after the lesson for next week, you'll write your reflective journal. Then after then on the 16th, so every other day, okay, you will be writing reflective journal. So I hope you will work on just do the readings, and I am looking forward. So I would just say I would be praying for you. I keep you in my prayers every day. I know that you have other things that you're doing, not only algebra, but by God's grace, you will surely be you will surely be fine in many, many ways. Okay, so if there are questions, okay, yeah, so let me stop now.